Hi. So in this video, we'll continue the course on integrals and we'll look at more problems today. Let's look at question number 7. This is integral from 0 to 2 x power 4 plus 1 divided by x power 4 plus 2 whole power 3 by 4 dx. So this is the integral that we want to solve, and we're going to think about how we can do a good substitution that can make matters easier for us, right? So uh, let's think through this one. Here, I cannot take x power 4 plus 2 as t because there is no connection to the dt here. Like if I take t is equal to x power 4 plus 2, I will get dt is equal to 4x cubed dx. But you need two terms here, and this is does not look like that, right? So the normal basic substitution doesn't work. So what we'll think of is modifying this integral slightly in order to make it something that will help us with a substitution. So for example, if I take x power x multiplied by x here and multiplied by x here, so what does it become? This becomes x into x power 4 plus 2 to the power 3 by 4. But this doesn't help us because we cannot take x inside this, right? And because there is a 3 by 4 power here. So if I wanted to take 1x inside, I have to put x power 4 here, right? So I will multiply by x power 4 here and x power 4 here. What it does is it helps us take x common and put it inside the bracket. So then what I will get is in the denominator, no, actually, if you put it inside the bracket, it will be very high power. It will be x power 12 that you have to put inside the bracket, right? So that will be incorrect. So I will think of this as, suppose you have x power 4 plus 1 here and x power 4 plus 2 to the power 3 by 4. So if I want to make it a higher power here, so let's multiply up and down by x power 3, right? X power 3 if I multiply up and down, right? So then here 3 can be written as x power 4 to the power 3 by 4, right? The denominator part. And this is x power 4 plus 2 to the power 3 by 4. So the denominator becomes x power 8 plus 2x power 4, 3 by 4. And the numerator becomes x power 7 plus x power 3. Now, is that useful to us? Let's try it out. Like if we take this as t, what happens? This becomes 8x power 7 plus 8x power 3 dx is equal to dt. Like if I take t is equal to x power 8 plus 2x power 4, right? So this helps us because we can write this as 8 times x power 7 plus x power 3 dx, right? Dt becomes this. So, and on top we have x power 7 plus x power 3. Therefore, you can write this as integral of dt by 8 divided by t to the power 3 by 4, right? So that will become 1 by 8 integral dt by t power 3 by 4. And that will become t power 1 by 4 by 1 by 4. So 1 by 2, since 4 and 8 will cancel, and you get it from 0 to 2. Put back the t. T is x power 8 plus 2x power 4 by 2 from 0 to 2. So the answer for this will become now if you put back t, it will become 2 power 8 plus 2 into 2 power 5. So 2 power 8 is actually 256 plus 32. So that becomes 200 88 by 2, 144, right? So try to understand what happened here. I was trying to take something as a substitution in the denominator, but if I do direct, it doesn't come because the top part is not fitting the dx that comes when you do the substitution. So I wanted to include something or multiply and divide by something in order to make it work. So I tried doing x power 4. It is x power 3 that works, because if you take x power 3, you can write it as x power 4 into 3 by 4 and take the x power 4 and multiply it out, right? And this becomes x power 8 plus 2x power 4, which can be taken as t now. And the numerator works out nicely because the numerator is x power 7 plus x power 3, right? So this is again a slightly tricky application of the method of substitution that we have been doing so far, right? Let's move on. This is the next question, question number 8. This talks about value of the integral e power sine square x cos x plus cos cube x dx, right? Not dx, it is sin x dx. Sin x dx. Okay, so let's think about this one. If you write it as e sine square x and take a cos x outside, this becomes 1 plus cos square x cos x sin x dx. And I know that e power x f of x plus f dash x, the integral by parts, it comes out to be simply e power x f of x. So since here it is a function of x, I should take sine square x as t to try to match it to this pattern, right? This integral. So if I take sine square x as t, you get 2 sine x cos x dx as dt. So the integral overall becomes e power t 1 plus sine square x. 1 plus sine square x is actually 1 plus cos square x is actually 1 plus 1 minus sine square x, which is 1 minus t. And cos x dx, cos x sin x dx is actually dt by 2. So what you get here is e power t 2 minus t by 2 dt. Now this is doable because this comes out as e power t minus t e power t by 2 dt. Integral of this is e power t minus half. You have to do integral of t e power t. You can do it easily by parts. It is t into e power t minus e power t, right? Doing it by parts. So the answer will become e power t by 2 minus t by 2 e power t. Now you put back your t, you get e power sine square x by 2 minus sine square x by 2 e power sine square x, right? That should be your answer finally, right? So how did we do this one? We just try to match it to this form. In order to do that, you will have to take sine square x as t, because in the form you have e power t, not e power function of t, right? Once you do that, after that, it's a matter of simplifying the integral in such a way that it looks like this form, and then you can just solve it. Like it's a very easy integral after that point, right? Let's move on. This is question number 9, and this talks about the integral sine 2x plus sine 4x minus sine 6x divided by 1 plus cos 2x plus cos 4x plus cos 6x dx. We have to integrate this. So the idea here will be to not try to integrate it immediately. First, try to simplify it a little bit using your trigonometric knowledge. So I know that sine 2x plus sine 4x is 2 sine c plus d by 2. So it's 3x, and cos c minus d by 2, which is x, minus this is 2 sine 3x cos 3x, double angle formula, divided by 1 plus cos 2x is 2 cos square x, plus cos c plus cos t is 2 cos c plus d by 2, cos c minus d by 2, so cos x cos 5x, right? Great. So taking stuff common here, on top you can take 2 sine 3x common, and it will become cos x minus cos 3x. And in the denominator, you can take 2 cos x common, and it will become cos x plus cos 5x, right? So both the top and the bottom, you can simplify again by using the identities. The top part, cos c minus cos t, becomes sine 2 sine c sine d, right? 2 sine uh, c plus d by 2 sine d minus c by 2. That is the formula. So this becomes 2 sine 3x sine c plus d by 2, which is sine 2x, and sine d minus c by 2, which is sine x. Notice, by the way, that this 2 cancels, and you have 2 coming out from here, right? This is the top part now, and the denominator is also 2 cos x. It is cos c plus cos t, so it is 2 cos, no, there's no extra 2, it's just 1 2, cos 2x cos 3x, right? Using the formulas again. Now you can see that again 2 cancels, and it is just tan x, tan 2x, tan 3x, right? So this integral, this whole expression is can be simplified as this: tan x, tan 2x, tan 3x dx, right? Once you have this, let's try to simplify this expression further by using the fact that 3x is equal to x plus 2x. Therefore, tan of 3x will be equal to tan x plus tan 2x by 1 minus tan x tan 2x, right? Therefore, that implies that tan 3x minus tan x tan 2x tan 3x is equal to tan x plus tan 2x. So this product expression can actually be written as tan 3x minus tan x minus tan 2x, right? Now this is 3 separate integrals, each of which we know the answer. It will be ln mod sec x for tan x. So therefore for tan 3x, it will be 1 by 3 ln mod sec 3x minus 1 by 1 ln mod sec x minus 1 by 2 ln mod sec 2x, right? So these are the answers that you will get. This is the answer. The question was basically about being able to simplify the trigonometric expression and make it come like this. Once it has, you have reached this form, after that you can use the fact that 3x is equal to x plus 2x, and you can write tan 3x tan x and tan 2x as the sum and difference of individual tans, right? If you do that, you can easily integrate. Let's move on. The next one talks about if integral g dash x by g of x minus f dash x by f of x whole thing multiplied by ln of g of x minus ln of f of x dx. We have to find out this integral. So, okay. Now here, this part is actually ln of g of x by f of x, right? And this is g dash x by g of x minus f dash x by f of x. This is the integral actually, right? So if I think of taking some substitution here, one thing you could try substituting is this one. So if you take ln of g by f as your t, your dt would become 1 by g of x by f of x, and then differentiating g of x by f of x, which is g dash x f of x minus g of x f dash x divided by f of x whole square, right? into dx. So your dt is coming out to be f of x by g of x multiplied by g dash x f of x minus g of x f dash x divided by f of x whole square, cancels one square, and you get by fx gx, which is equal to dt is equal to, now fx gx, if it comes, you divide it, you get g dash x by g of x minus f dash x by f of x, because here f of x gets cancelled and here g of x gets cancelled dx, right? So notice that this is the same expression that was here. This is basically becoming your dt. So what you are getting is integral of t dt, which will become t was this, so it will be t square by 2. So it will be half ln g of x by f of x whole square. That comes out as your answer for this one, right? So hopefully you are understanding how we got this one. It is fairly straightforward. You just have to come up with the right substitution. Let's look at the next one. Question number 11. And in this one, we look at integral of cos power 6x dx by sine power 4x and cos 7x plus sine 7x to the power 4 by 7, right? Now, a standard technique while doing integrals where there are powers of sine and cos is to divide by the right power of cos x in order to get a sec x, sec square x or something like that on top and tan x on the bottom. So if I want to make a tan x here, I have to divide by cos power 7x, right? So I'll do cos xx, cos 6x dx, sine power 4x, cos 7x plus sine 7x by cos 7x, right, to the power 4 by 7. So technically, if this comes out, it is 1 by cos 4 power x. So that means you have to multiply by 1 by cos 4 power x on top also, right? Then only this operation is justified. So what you get is basically you get cos square x on the top, cos square x on the top, because cos 6x by cos 4x and dx, and divided by, you get sine power 4x and 1 plus tan power 7x power 4 by 7, right? So again, dividing by the right power of cos x, I want to get a sec square x on top, so I have to divide by cos power 4x. You get sec square x on top and divide by cos square 4x here, it becomes tan power 4x, 1 plus tan power 7x to the power 4 by 7, right? So what we get now is dt. If you take tan x as t, you get dt by t power 4, 1 plus t power 7 power 4 by 7, right? Okay, correct. This is coming as my integral. So what can we do here? So let's multiply by t square and become t power 6. So t square. Okay. I feel like I made a slight misstep somewhere. Let's think. What can we do? We have sec square x by tan power 4x, 1 plus tan power 7x. Oh, okay. Actually, it is correct. This is correct only. Uh, we have to think of what we can do here. So we have, let's divide by tan 7x here. Take tan 7x out. So you'll get sec square x dx. And if you take tan 7x out, you will get tan 4x. So it will become tan power 8x here. And it will become tan power minus 7x plus 1 to the power 4 by 7. Right? So this is my integral. And if I simplify this by taking 1 plus tan power minus 7x as your t, let's see what happens then. 1 plus tan power minus 7x as your t. You have dt is equal to minus 7 tan power minus 8x multiplied by sec square x dx, right? So this is minus 7 sec square x by tan power 8x dx. This is your dt. So minus dt by 7 is equal to sec square x by tan power 8x dx. So you get the integral minus dt by 7, and this is your t power 4 by 7. And now it is straightforward. By x power rule, you can easily integrate this. So one key idea that you learned in this question is the idea that if you divide by appropriate powers of cos up and down, then it might help you simplify the integral a lot. So appropriate powers of cos up and down in order to get a secant square x on top and some tan terms on the bottom. That might help you to take tan x as equal to t in the next step and basically solve the integral. So you should be aware of this particular method. You will see applications of this as we go along in the future videos. Also, while doing this course, make sure that you try the problems before. I cannot stop the video and wait for you guys to solve it. So you need to pause the video and check out the solution, try to get it yourself, and only then look at the solution. So that will help you learn and retain the stuff that we are discussing for a much longer period. That's all for now. Let's discuss further in the next video. See you next time.